Screen share.
Good evening, everyone. I'm Ashish George from Goose. Hi, a very warm welcome to all joining us today. I hope you've all had a wonderful day so far. It's truly inspiring to see so many professionals and learners taking time to join this session, even after a busy schedule. Your presence here shows your commitment to continuous learning and professional growth. Today's webinar is an initiative by Goose Industrial Solutions in association with Goose Elevate Industrial Automation Training Department. The objective of this initiative is to empower industrial professionals and aspiring engineers by enhancing their knowledge and skills in the field of industrial automation. In today's rapidly evolving industrial landscape, upgrading our technical skills is no longer an option, it's a necessity. Programs like these are designed to bridge the gap between theoretical knowledge and the real-world industrial application. Now, without further delay, it's my pleasure to introduce our esteemed speakers for today's session. First, we have Mr. G. Santony, Manager, Automation, with extensive experience in handling automation projects and industrial solutions. He brings valuable practical insights and industrial expertise to our discussion today. Joining him is Mr. Eben Chandy, Team Leader, Automation, who has significant experience in industrial automation systems and will be sharing his knowledge and practical perspectives during the session. We are truly privileged to have both of them with us today. And I'm confident that this session will be highly informative and beneficial for everyone attending. So once again, thank you all for being here. Let's begin this exciting learning session. Handing over to Mr. G's.
Good evening, everyone. We are starting the session. The session is mainly focusing to upgrade your skills in industrial automation, and we'll be covering industrial networks in the protocols like Modbus TCP, OPCUA, MQTT, and we'll be covering some sessions in industrial network security also. When it comes to industrial network security, most of the industrial automation engineers thinks that network security is a very big burden, and we cannot get an understanding of industrial network security. But in this section, we will be covering a very basics and hoping you understand the security level also uh, uh, in a simplified way. Okay. By the end of the session, we will be expecting you to uh, troubleshoot these network issues if you are dealing the troubleshooting sessions in the factories and your working environments. So we are focusing the session in first session of the session. We will be focusing on uh, Modbus TCP and OPC communications. And the next section, we'll be covering MQTT and its secure communication way of secure communication in between the factory devices and cloud. And in the OPCUA and Modbus session, we will be having a uh, demonstration of the communication with live communication in between the PLC and PLC with and a Modbus OPCUA client. And we'll be expecting you to diagnose very better after this session. So in every industrial network protocols falls into different categories. We are categorizing the network protocols based on how it is designed and how it is used in the industry. So from the starting level, from the field, we can see that there are multiple protocols like PROFINET and Ethernet IP, and IO link, which is to communicate with the devices in the field and the controllers. And the next layer is the controller layer, which is actually mainly that comes the DCS and PLC controllers, and also the VFD and servo like controllers will come in that session. The next level of the session, we can have SCADA and HMIs, which is actually where operators will be interacting with the machine. And above that, we can have business value creation sessions like centralized SCADA and MES systems, ERP systems, like which is used to create business values in the industry. And nowadays, all the communication protocols uh, cannot communicate to the cloud system. So we have specially designed communication protocols that we can use to communicate with the cloud system. When it comes to cloud systems, we are taking the data from the factory to the outside of the factory, and systems like centralized server and cloud hosted PCs. We will be giving that data to the cloud hosted PCs. So these are some of the protocols we are commonly using in the industrial network landscape. We, the PROFINET and Ethernet IP would be considered almost similar, which is actually one protocol is handled by Siemens, which is PROFINET, and another one is handled by Allen Bradley, which is Ethernet IP. And Ethernet IP can be seen in with another manufacturers like Schneider and Omron. So PROFINET is actually mainly developed and maintained by Siemens. Both network protocols are very strong in the industry, and have been used in the industry for a very long time. Modbus RTU and TCP is actually two very commonly used open protocols. Modbus RTU is actually a serial communication protocol, which is the physical layer is RS-485. And Modbus TCP is actually Ethernet-based protocol, uh, which we can see that Ethernet is actually a common industrial network protocol that is getting very popular in nowadays. Modbus TCP and Modbus RTU is actually in a protocol wise it is very similar, and if you use any of the Modbus RTU and TCP, the knowledge can be switched in between the two, and which is considered to be one of the simplest protocols in the industry. And we have OPC UA and MQTT, which is actually um, one is actually OPC UA is actually a newly addition into the industrial communication protocol, and mainly OPC UA is used to communicate between the controllers and the uh, outside of the controller, like ERP station and MES stations, manufacturing execution stations. Why? Because it is that OPC UA is actually released as an open protocol, and in the recent years, we can see that most of the controllers equipped with OPC-UA, and because of OPC-UA, we are avoiding a lot of licensing costs, and simplicity of development comes in an advantage of OPC-UA. And MQTT is actually a very lightweight protocol, which we will be covering in depth in the session, which is actually used to communicate communicate between factory floor devices to the cloud. Since it is a very lightweight protocol, we can see even in the sensors itself, we can host an MQTT client server, which can communicate to the cloud system like MQTT server. We are covering Profinet and Ethernet IP here in a very brief. Actually, Profinet and Ethernet IP is actually a real-time protocol. When it comes to industrial controller level communication, the real-time communication is very important because most of the signal exchanges and data exchanges has to be happen in real time to make the control system behave with an expected outcome. Without the time criticality or time-based, without the time-based communication, most of the control systems could not perform in a deterministic way. That is why in, we are maintaining the time-based communication protocols like PROFINET, Ethernet IP, and EtherCAT. And in PROFINET, we have two performance classes. One is real-time and one is isochronous real-time. Real-time is actually it's a normal communication with PROFINET devices, which can take 1 to 10 millisecond latency based on the communication load and how many devices you have hosted in the plant. Based on that, this communication latency will vary. But IRT is actually used to used to communicate in between motion control and synchronous multi-axis applications and robotic applications. IRT is more time critical and which can give you a time specific time interval of below 1 millisecond communication with a Modbus IRT. And with the Profinet, it's actually it's not a uh, two different protocol when it comes to physical layer of Profinet. It is actually same Ethernet switches and Ethernet connectors and cables we can use with the Profinet. Ethernet IP is actually very similar to Profinet. Actually, the protocol layer and the standard difference of Ethernet IP and Ethernet is actually Ethernet IP is actually exchanging the data in between the devices with a standard called CIP. CIP is actually the principle of data exchange between the Ethernet devices. And Ethernet IP and Profinet is actually maintained by two different parties, and the manufacturing of the controllers of Ethernet IP is also maintained by two different manufacturers. One is Siemens and one is Allen Bradley. That kind of difference you can see in Ethernet IP and Profinet because Siemens is focusing on much more faster communication. That is why we can see very better latency in Profinet. Ethernet is actually very closer to common Ethernet devices, so that data exchange between Ethernet IP devices and other PAN devices is very would be very easy. Next session we will be covering very deep in Modbus TCP. So for that, I am switching over to Abin.
Hi all, hope you're having a good evening. So I believe most of you have heard about Modbus TCP or Modbus in general. If you go to any factories, you can see at least one device working with Modbus. Okay. Now, if you go to any factories, you can see at least one device working with the Modbus. Yeah, it's been 40 years since Modbus was introduced. It's still active in most of the industries. The main reason is because it's very simple and reliable communication. So also it can be worked with RS-485 or TCP/IP. It's very uh, easy to troubleshoot. So it was introduced in 1979 by Modicon, still running in active plants every day. So as I said, it's extremely simple, easy to troubleshoot. Most of the technicians in the field can understand and troubleshoot if any issues comes or the system is not working. Most of the technicians can easily understand, or someone can easily guide them to troubleshoot the issue. There is no encryption. The licensing is free. The most of the manufacturers support libraries or directly support a Modbus. So it's very commonly used in industry. Actually, Modbus is Modbus is available in different forms. Modbus RTU is there, Modbus TCP is there, and one more is there, Modbus ASCII is there. So what are those? So basically the language is the same, the protocol is same, but the hardware layer is different. Modbus RTU means it's running on RS-485. Okay, the Modbus RTU is it's running on RS-485, and Modbus TCP means it will be working with Ethernet. Where it's like we are communicating our phone or via directly talking or via email. It's just like mode of communication is different, but the language is same. The language is Modbus, and the mode of communication is TCP or RS-485. RS-485 will be serial, and the other one will be Ethernet based. So the working is like there one master will be there, multiple slave devices will be there. So master will be asking the slave devices for its data, and the slave will respond with this data. Only one communication will happen at a time. So suppose I have one VFD is there, one energy meter or any device is there. I can suppose I am the master or a PLC will be the master. The PLC will be communicating with the slave energy meter for its value. Suppose I want to give read the power of the active power consumption, then the master will be requesting the slave device for its values, and it will be responding with its value. So it will be communicating with the energy meter, then it will be communicating with the VFD. Everything will be connected in a single network. So because it's in a single network, each of them will be having individual IP addresses. So IP address one will be master will be communicating with the first address. Then after receiving the data from it, it will be communicating with the second address. If you want to start the VFD means you have to write to the VFD. One start command you have to give. So the read and write and will be different commands will be there. Function, it's known as function code in Modbus. Different Modbus is having different function codes. I'll explain it later. Modbus is having different address areas like coils will be there, input is there, input registers are there, holding registers are there, output registers will be there. Coils and input is a discrete input means it's a single bit data. It's like coils, output is turned on or not. Coil is the output, digital output. Either on or off will be there. If the output is on or off, if the valve is on or off, only the status. Output will be read or write. We can read the output status, or you can write to output directly. And the discrete input is the digital input from the field. It's like one level switch, maybe pressure switch. It's on or off, only one digital input will be getting. In the input register, it will be mostly sensors. Analog sensors are there. If you want to read the temperature, if you want to read the pressure, everything connected from the field to our slave device will be coming in the input registers. Holding register is the interesting part happens. So that's where all the parameters, all the set points. Suppose we are controlling one PID controller or the VFD. So if you want to give a set point to the VFD, that will be coming in this holding register. So most of the communication will be happening with the holding register. That's where the scaled field values will be coming. That's where the set points will be coming. All the parameters related to the system working will be coming in the holding registers. So I told you about the function codes. It's actually built inside the Modbus protocol. You don't have most of the time you don't have to directly interact with this function code. If you are using the one library, that library will be taking care of these function codes. So function code one is there. That means read coil. As I said earlier, coil is the digital output of the device. So if you want to read the status of the output, we can use function code one. And function code three is for reading holding register. Holding register reading 16-bit data will be there. That data you can read using this function code 3. And if you want to write to the single register, you can use the function code 6. All these three codes are the most common. Now, the 90% of the communication using Modbus will be happening is with this codes only. There are other codes also, but these are the main ones. So the main question is, suppose your plant is having one Modbus TCP device. You want to integrate that system to your new one another SCADA system or PLC system, you want to integrate that. How can we do that? So for that, you don't have to disturb the plant. If the plant is still running, you just want to collect the data or just integrate the data monitoring with the new system. So what we can do is you can identify the IP address of the device. Every Modbus TCP supporting device will be having IP settings. So you can set the IP address. If it's an RS485, RS485 Modbus RTU device, either you can use Modbus RTU master or you can use converters in the middle. Uh, you can then you can get the documentation for the Modbus registers. Every Modbus devices will be having Modbus register map. So like what all the parameters, your speed set point, your pressure, your level, every parameters related to that device will be listed with the address. So you can get the register map from the manufacturer websites. So you can download it. You can use one Modbus tool, software scanning tools will be there. One Modbus Pol is one example. So you can download the Modbus Pol software and connect the device and check the register values. After you check it and confirm the Modbus is working and active, you can integrate the same thing with your PLC. So in the PLC, you will be having different libraries like for Siemens PLC, we have MB Modbus MB master block will be there, MB client will be there. Like these blocks, we can configure for the serial or Modbus TCP applications. Like that, we can integrate the existing system to a new PLC system. So with that, we can just move on to the OPC UA section. I will hand over to Jees to he'll demonstrate you on the OPC UA.
So let's discuss something about OPC UA, and we'll have a demo on this both of the sessions, Modbus TCP and OPC UA. And OPC UA is actually it's not just a better protocol. It created a universal communication standard like Modbus TCP. Modbus TCP was very good. That is why it kept evolving from the 1979. So it was created that long, and it survived this many years. So that means it is very strong protocol, but it has some issues when it comes to modernizing the plan. So like the security and the scalability. So you can see that in the live demo session, the OPCUA has to be we have to keep looking on the register addresses to and we have to keep the register addresses to understand what is coming in that OPC Modbus TCP network. But OPCUA is actually something like a describable network accessing protocol. We'll see that in the actually a little bit of how OPCUA came into the picture. Uh, Before OPCUA, every vendor has their own protocol and their own language. Like if you use a Siemens PLC, Siemens will have a specific protocol like S7 protocols, and with Allen Bradley we will have a specific protocol to access data from Allen Bradley. And with each and every vendors, you have to keep looking for their manuals and keep developing the communication application to collect data from each and every manufacturers. So the pain point was we have to develop and maintain, and even the troubleshooting time also we have to keep looking into each and every manufacturer's documentation to understand it in depth, to troubleshoot and to keep that communication going for a long term. So to solve that in industry, we have introduced OPCUA. With OPCUA, with a single standard, can communicate with every every vendor manufactured devices. And since It is a very standardized protocol, uh, and it is a very modern protocol. The security and the scalability, like the name servers, like plant level name servers, we can keep with the OPC way. So in the slide, you can see that this is an example of how we collect data from OPC way. This is actually the UDT data is actually the same data representation with the Siemens PLC. That UDT data, uh, with what name we have represented in the Siemens PLC, we can collect directly with the same name, and other details like the what are the data type it contains, and what is the unit of that reading, like that rich details we can convey through OPC way. You can see that in the example of one of the OPC data structure. We can see that factory dot line dot motor one dot temperature, which means that we can divide the entire factory into separate divisions, and that separate divisions even divide into particular sections to understand the name server properly, which is actually a complete standardization of industrial data communication in between devices, which came through industrial 4.0 standardization. With OPC way, we can very easily achieve this. If you use any other standards, you have to make it by yourself. You have to keep the standard by yourself. So maybe something like you have to keep that standardization of data sharing in between controllers. If you're using any specific vendor like protocol, you have to keep your documentation separately. But with OPC way, this standardization of data exchange is standardized across the industry, and it is maintained by international organizations, so that when an update comes, everyone follows this OPC standard, will be updating their own controllers, or their own implementation of OPC in the devices will be updated as well. So that is why uh, we can maintain the data exchange with OPC devices very clearly. And one example we have shown in the above, which is actually from the Modbus TCP. You can see that 40,001 is actually a holding register in Modbus TCP, which have a value of uh, 20,340. Actually, this 40,001 holding register holds a value of 2340, and which is actually we cannot understand what is the actually whether it is a motor value, whether it is a energy meter value. We cannot understand clearly from the register itself. But in OPC way, we can solve that problem by introducing the name server principle. That is a very important point of implementing OPC way in factory. And another standardization comes in the namespace, which is actually when it comes to standardizing an entire factory to a centralized data server, we can see that a unified namespace standardization, like um, with OPCUA and MQTT, can implement this unified name server principle, like we have discussed in the um, OPCUA data structure, like factory.line1.motor1. With that, it's a long-term implementation. With that, we can keep this data without modification for a long time, so that your data comes under the namespace. Another consideration when it comes to upgrading communication protocols like Modbus TCP to OPCUA is security. Security is actually built in with OPCUA. With Modbus TCP, if you want to secure a Modbus TCP network, it is very difficult, because we have to maintain the security externally. For example, if you have a Modbus TCP device in the plant, and it is connected to the central network, to the factory. Anybody from the central network can access the Modbus TCP network and data. And with security principle broken, anybody from the hacker world can access and control your device if you are using Modbus TCP. And if you are not protected that Modbus TCP network, you cannot protect the Modbus TCP communication in the device level. But with OPC the industry standard security protocols like transport layer security and sign-based access can be very easily implemented. You can see that in transport security, the transport security division, the uh, with the transport security, the messages in between two devices can be encrypted. Encrypted means from the device one end, it will be encrypted to a specific code that a third party cannot be understood, cannot be understand. If you're using WhatsApp and other messaging platforms, you can see that every messaging platform is currently using encrypted protocols because otherwise anybody can look into the data like a third party person. Same level security we have to implement in the industrial devices because if a third party person can access to the control circuits and control networks with access to the control networks, somebody can manipulate the data and which can cause a security failure to the machine and even a safety failure to the human being itself. So that's why security in nowadays a very important factor when it comes to implementing something like a network communication. So with OPCWay, we can have two security standards. One is certificate-based encryption, which is called X509 certificate. 509 certificate is actually a standardized security certification with X509. We can generate a certificate from both two devices. For example, if you're using two devices to communicate each other, we can generate a certificate from each end and share with each other so that without certificate, these devices won't allow communication. That is how we achieve certificate-based encryption and authentication. So with OPC this is very standardized, which is very easy to maintain the certificate, very easy to generate certificate with every OPC certificate devices and every programming interfaces that implemented OPC have a standardized way to generate certificate and exchange certificate. So we will have a demonstration with that demonstration. We can see that how the certificates can be generated and exchanged. So another type of authentication method in OPC is the username and password method. This is actually two different security principles which is implemented in OPC. You can use both this username based security and certificate based security in the OPC network so that it will have the most advanced security based network in the plan. And with OPC this can be implemented very easy. If you are using any other protocols, this will be very difficult because each and every manufacturers uh, will have their own standards in implementing it. With OPC you have a standardized implementation principles. If you have learned one device implementation with OPC you can very easily apply it to the next device. That is the main advantage when it comes to OPC And next, for layer three, we can, which is actually an advantage of OPC which is actually we can have type of authorization. Like if you want to give only read access to the client, uh, which is reading from the server, and we can have a standardized control over the client that client can only read or another client can read and write. So we can have two different type of authorization methods. Okay, so in the security modes, you can see that OPCUA can be implemented without security. It is actually not recommended. But other type of security is that sign and encrypt, which is actually we are recommending to use sign and encrypt method. It can be very easily implemented with OPCUA. We are recommending to use sign and encrypt method because which will give you the most advanced security level when it comes to exchanging the data in between devices and ERP level. Okay, we'll have a demo session. With the demonstration, we will be, you can see that we will be implementing a Modbus TCP communication and also PCS communication. And we have opened a chat session where you can ask questions or any doubts or any suggestions in this webinar, which is open in as a chat session. If you have, hope everyone can access it, and you can ask questions. We will have a session after completing the presentation. We can clear that doubt and suggestion.
So right now we have set up here for the practical demonstration. Here I have one PLC and another PLC setup. Both of them are communicating each other. So this one is one Modbus server. Modbus slave is there. This is the Modbus master is here. And from this one, we will be taking, this one is OPC UA server. From this, I will be taking OPC UA connection to my laptop and I'll be sharing the screen with you. I'll just demonstrate whatever the settings we have done, and OPC UA connection I'll be sharing. Screen sharing.
Evin, I think you are muted.
Yeah, I was muted. Yeah. Now I'm audible now?
Yes, you are audible.
Yeah. Okay. This is the TIA portal. This is the PLC programming software from Siemens. TIA stands for Totally Integrated Automation. So from the software, we can develop the PLC, SCADA, drives, every configuration we can do. So in this this is a demo project. In this project, what I have done is I have added two PLCs. And like I shown, the PLC one is having the OPC UA setup. PLC two is having the Modbus slave setup. So I'll just start with the PLC two. If you expand this PLC two, you can see the program here. In this program, you open the main program. Here I have created one Modbus server. So here I'll be creating. I can add data here. Whatever this is my Modbus data. Whatever the data I'm creating in this data, I can access from this PLC one. In the PLC1, here one MB client I have created. Client is the master, server is the slave. In the server which is the PLC2, here I have added the data. This data I have added here, and the connection parameters I have added here. This will be the settings for the Modbus server. And for the PLC1, I have added the connection request, disconnection request, mode of communication, and the Modbus address, Modbus data length, whatever the data length we need, how long data we need, all those parameters I have added. When I go to the program online, we can see the Modbus address as 4001, and the data length is 100. That means I'm taking from this address 100 length of data and storing to this location, MB settings dot data. So if I'm going to MB settings dot data, this is the location. As you can see, the left side values and right side values are same. So if I change some value here, suppose I am entering 23. Same value reflecting in the PLC2. That means the PLC2 is communicating with the PLC1. All those data from PLC2 is reading to the PLC1. So this is the Modbus TCP communication. This is communicated using Modbus TCP. And for the OPC UA communication, this is one free software called UA Expert. This is used as an OPC UA client. Okay, from here we have to add servers first. So we have created our PLC here. This was the IP address of the PLC with the OPC server. Here we can see 1200. For now, I'm 3 encryption modes is available. I have configured the without security. So I'm going with the without security one. It's connected here. So I'll just click on connect. So you can see whatever the data I created, the same data is coming here. Huh? Okay, so I'll go back to TIA portal.
So in this session, we are communicating from the PLC to the OPC client. You can see that we have a network disconnection here, but with the modification of any data in the PLC, you'll be getting that value in the OPC client. So we have implemented for the demonstration. We have implemented non-secure way, but in factory you have to implement it in secure way. So with secure way, nobody can access your data even in between from the network communication. That's a very big advantages when it comes to OPC way. Every other manufacturer is coming with OPC way with their controllers, and every other communications like PROFINET and other real-time communications is also thinking of implementing this secure way of communication. So you can see that if you are following the industry, Siemens has introduced S7 plus communication, which is actually a secure way of communicating with Siemens controllers. So if you modify the data here, you can see the reflection in the OPCWA client itself. So modifying it with 220. So we're expecting to see that 220 in the OPCWA client itself. Yes. No, data. Uh, Temperature has modified now, so that value is exchanged. So we have demonstrated how the communication happening in between two PLCs with Modbus TCP, and from um, PLC to the application, which is actually a OPC client, uh, which is an OPC web. Next section, we will be introducing MQTT. So, sharing the screen. So, we are introducing MQTT. MQTT is actually a protocol that is mainly used to communicate with the cloud system. But you can use it in other levels also. But in our in our project, we use MQTT to communicate with the cloud. It is a very, very good protocol because in whatever we are experiencing as a difficulty in the industry, like less speed internet connection, latency internet connection, and network disruptions. All the things, and as well as the security, like we have discussed in the OPC way, how do we implement the higher level of security when it comes to industrial communication protocols, which is actually comes by default in MQTT, the TLS level security, and with since MQTT is taking plan to the cloud, so security is very important here, and most of the MQTT communication has to be protected if you are taking the data from the plant to the cloud, and uh, we are from the Goose project level, we are using MQTT protocol to communicate with the cloud and build dashboard like this. Seen you've seen uh, this type of dashboard, which is hosted in the cloud, can have a backbone of MQTT with the secure communication. And a little bit of history of MQTT, which is actually created by IBM in 1999. Comparatively new protocol, which is actually created to communicate from the oil and oil and gas industry sensors. So at that time, the network latency and bandwidth was very difficult to communicate in between systems. So the protocol MQTT was designed from the base up to accommodate those difficulties. And since it is extremely lightweight, even in a small sensor with communication like SIM card based 4G based communication or Wi-Fi based connection is available in the sensor itself, we can implement this MQTT clients in the sensor itself. So when it comes to MQTT, a push based communication, which is once we establish the communication with the server, in the MQTT, because the client is sitting in plant level or field level. We can have a push-based network, which is when a value changes in the client or the sensor can push the data at the time of change to the cloud, which makes the communication bandwidth and size of the data exchange keep keep this kind of push-based network will be keeping the bandwidth very less. So, so you can see that this communication different communication protocols and how where it is implemented. In OPC you can see that it is implemented from PLC to gateway or edge devices. Edge devices means if you are collecting all the data in a centralized device in the plant itself, you can consider it as an edge device. And you can have an aggregation of the data there and take the aggregated data, only specific data to the cloud. So we normally take the data from the MQTT client to the broker. So broker is the data collection agent, which will be sitting as a central communication medium. So the data will be coming to the broker, and it will be distributed to a database or any other client which is sitting in the connected to the broker. So we normally use the broker to store the data in the database and build the data and build data dashboards based on the data received in the database. So that is how we are implementing communication in between factory to the cloud. This is actually a method of data structure of MQTT. You can see that the OPC way and MQTT way, which is lot similar, because we can categorize the data with this method, which is actually like we discussed in the unified namespace. With all the data coming from the factory, it's very difficult for you to determine with a single data level from which area it is coming. So with OPC UA and Modbus MQTT standardization, we can have a unified namespace in between all the data coming and communicating in between factory and in the sensor level itself. You can categorize the data very easily. And MQTT is actually a publish subscribe method, which means we can have a publisher and a subscription subscribers in the same MQTT network. So publish and subscribe means, for example, if the sensor is generating value, you can publish to the MQTT server, and every subscriber, that means, for example, our mobile device or our data collection agent, which is sitting in other side of the internet, can subscribe to data. So whenever the publisher subscribing particular data, subscriber can be collecting the data as a subscriber. That is how the MQTT protocol basically works. It's a publish subscriber based network. So a basic introduction to the security. When it comes to industrial security or cyber security in the industry, most of the people would think that it's not their cup of tea, because it is considered as one of the difficult difficult subject when it comes to industrial networking. So we are considering security is managed by only a particular division of people. So uh, in the field visit and in most of the discussions with the client, we are making them understand what is the importance of security and how simple is to understand security. And most of it's not completely simple, because most of the cases can be implemented with a dedicated engineer. But there is a security level that everyone in the automation industry has to be understand. Like we discussed in the OPC UA and MQTT and Modbus TCP communication methods. Modbus TCP is considered to be an open communication because it can be read by anyone in the network. But when it comes to OPC UA and MQTT, there is a standardized way of securing the communication. It is actually a basic of cybersecurity because we are just encrypting the data between two devices so that the third party cannot be understood or cannot be accessed or control the device we are communicating. That is a very basic level of security everyone can understand. So, so and we can see that in the factory level, most of the PC and most of the devices we have to give access to remote access and SCADA systems connected to MES systems and ERP systems has to be secured by default. So this kind of security that we have discussed already, the certificate-based security and user-based security, like sign-in methods and role-based access. Like once the operator has signed in with a particular credentials, like who have designed to give access to that particular value modification, like set point modification, has to be followed in the industry. That's the security principles where we have to keep looking in. And since AI has evolved, we can see that lot of things happening in the cybersecurity industry level, which makes plant shutdowns and a lot of losses in the factory. So we have to give importance to the cybersecurity, and these kind of secure communications has to be implemented when it comes to and then communication between the network. So a little bit about X509 certificates. You have seen in the OPC communication. X509 is a certificate which is actually a kind of a passport. Like we can generate from, for example, if you're communicating between two devices, this certificate X05 X509 certificate can be generated from the both devices and exchange in between the devices so that the identification can happen with this certificate. This is an encryption standard. With generation level itself, this certificate will have a code that contains the identification of the server and client. So we can have these kind of certificates in PCUA and MQTT and HTTP as well. So a little bit of what we have covered in this session. We've covered the PROFINET communication protocol, how it is working, and Modbus TCP and OPC UA, as well as MQTT. So each communication protocol serves its purpose, and each has to be maintained in its own way to keep the devices communicating in the factories. So yeah. Okay, what we have covered in the section as a certificate-based authentication and in the security level, what we have covered as an X509 and port hardening is actually a security principle that, for example, if you are communicating in between two devices, you have to make only available protocols. Like, for example, if you are communicating with Modbus TCP, mostly Modbus TCP will communicate with 502 port. So other ports you have to disable by default. Every devices will have a security principle to disable the ports. That is a security principle to maintain. We have some questions in the session. I'll go through it. Izan has asked, an OPCUI run directly from Siemens PLC without a gateway. Of course, you can check with the new Siemens PLCs. Almost every PLC like S1 1200, S1 1500, and ET200 PLCs comes with OPCUI in a standard as a standard. Now we can communicate with Siemens PLC, new PLCs without any middleware. But with old PLC like S1 300 and S1 400, you can you have to have a middleware which will communicate with the PLC and convert it into OPCUI. But with the new PLC, you can have OPCUI directly implemented in the PLC. Alind is asking why in Modbus TCP server is considered as a slave. Okay, Modbus TCP server is considered as a slave because server is actually um, server is actually giving the data to the client. Client is asking the data from the server. That is why client is considered as a master. In Modbus TCP, in Modbus protocol, we can have in RS485 itself, master will be asking the data and slave will be giving the data. So the same principle is followed in the Modbus TCP as well. So whoever asking the data will be considered as a master, and whoever giving the data is considered as a slave. So since in Modbus TCP, server is giving the data, so it is considered as a slave. Can we get a training after the session if required? Any contact number. So we will be sharing the contact number with everyone. You can have feedback, and if you have any other section covered in the coming webinars, you can share as a feedback. And of course we have dedicated training for professional engineers in as a part of whose Elevate program. So we'll have a introduction of that as well in this webinar. So we'll get an information how we will you can contact Goose Elevate for dedicated training. So Rahul Dev is asking, will there be a data breach when communicating with OPCV and Modbus or PROFINET? Of course, that is what we have covered in session. That this is actually either you have to protect your network, not giving access to any other person, like protecting the network with VPN or with managed switches. You can protect the network. Otherwise, you have to use, if it is an open communication, like if the communication is happening from the ERP level to the controller level, it is recommended to use OPCUA than Modbus TCP, because Modbus TCP can be accessed without any security difficulty. So that is why we are recommending to use Modbus TCP, OPCUA. Mency is asking if the instruments in the DCS control room are all showing bad values, where would be the communication failure be coming from, how to fault to be found. So, Ebin, answer.
Yeah, if the instrument is showing bad value, multiple location failures can occur. So you can first check the sensor. Sensor, if it's a, so I'm assuming it's if it's a milliamp sensor, uh, you can check if it's a milliamps is coming or not. From first point, you can check the sensor side. The power supply is reaching the sensor. May power supply failure can occur. Wiring failure can occur on the module terminal loose connection or something can occur. First, you can check if the voltage is coming to the sensor. If the power is okay, you can check the it's a milliamp. If it's a milliamp sensor, you can check the current is coming or not. You can connect your multimeter in milliamps mode and connect it in series and check the current is okay or not. If the current is okay, you can check the terminal side. Inside the panel, the termination is okay. Any cable breakage or something. There is also okay means you can check the module side if it's okay. The configurations are okay. So in most some modules there will be you can configure it in milliamps or voltage. If it's in different configuration, it won't work. So you can check that. If everything is okay means the value should be coming. Any settings in the program or something, it's missing the value.
Huldev has asked, how does OPCUA maintain secure communication in resource-constrained devices like embedded controllers or PLCs? OPCUA devices, by default, it has some resource constraints like we have discussed in the MQTT. MQTT is a very lightweight protocol so that it can be very easily embedded into very small devices. But OPCUA is a little bit heavier than MQTT. It has resource constraints. So, but by standard, OPCUA devices will have a security principle implemented. But MQTT also have security principles by default implemented. So, if you are looking in the embedded devices, mostly you will be using MQTT than OPCUA. But if the embedded devices itself have more hardware capability, then it would be easy to implement OPCUA. Vishnu Raj is asking, what happens if two masters exist in Modbus RTU? Actually, with Modbus RTU, you cannot have two masters. By standard, Modbus RTU is allowed to have only single master. But there are some workarounds, but it is not recommended in industry practices because Modbus RTU have only recommended to have only one master. But with Modbus TCP, you can have multiple masters asking client. Uh, Multiple masters can ask the client. Janish, can you share the recorded session? Yes, sure. We will have the recorded session, and we will be sharing with all the attendees the recorded session. Sujit is asking how to set a register length in Modbus TCP. It is a standard principle. It's how this Modbus TCP communication is happening. By standard, you have to give which register from starting, which register you're accessing the data, and how many length you are requesting the data. So with like Siemens will have particular Modbus block, which we have a field to enter the length of the uh, registers, and every other vendors will have their own blocks or communication interfaces to set Modbus TCP communication between devices. So you have to follow each and every manufacturer's documentation and block standards to give how to give this how to set this length of data. Hope every doubts are clear.
If there is no other doubts, I think we can wrap up. Ashish, your mic is mute.
Thank you, Mr. Eden. Thank you for this session. I would like to sincerely thank our speakers, Mr. G's and Mr. Eden, for sharing their valuable knowledges, practical insights, real life industry experience with all of us today. I would also like to thank all the participants who joined this webinar and took time to invest in learning and upgrading their skills. Your enthusiasm and commitment to continuous learning are truly appreciated. The session was organized by Goose Industry Solution in association with Goose Elevate Industrial Automation Training Department. Goose Industrial Solution continues to provide reliable, innovative industrial automation solutions, while Goose Elevate focuses on developing professionals through practical training and industrial-oriented programs. Together, both organizations are committed to support industries and empowering engineers and technicians with the knowledge and skills required for today's evolving industrial environment. We hope today's webinar has been informative and helpful for everyone. We encourage you to stay connected with Goose Industrial Solutions and Goose Elevate for upcoming webinars, training programs, and industrial learning opportunities. We also provide courses and professional guidances for everyone. For any inquiries, you can contact us through our email IDs that we contacted you or the WhatsApp number we've been contacting you. We will be circulating a feedback form soon. Kindly let us know your valuable opinions on the session. Once again, thank you all for joining us today. Have a wonderful weekend and we look forward to seeing you again. Hope to work with you in the future. Thank you.